Hi, everybody. I'm just going to do a recording really quick to help you a little bit with the intro assignment for the Unit 3 project, since I've already had a lot of questions about it. So to start with, if we're looking at this intro assignment, on question 1, this is going back to what we talked about back in chapters 2 and 3. So actually it was probably weeks 3 and 4 instead of what it says there about weeks 2 and 3. But anyway, this is just asking you about different types of graphs and different types of statistics that are meaningful and useful for quantitative data. So for example, things like bar graphs are not. Those are more for qualitative data. Things like pie charts, those kind of things are not what we're looking for here. So for example, for graphs for quantitative data and displays, you could do things like frequency distributions, you could do histograms, box plots, some of those type of things. And where it says statistical measurements, we're talking about things like mean, median, standard deviation, things that you calculate from quantitative data. And as it says here, please don't list a scatter plot, because for this project we're just talking about one variable, and scatter plots are only appropriate if you have 2 variables. Okay, that was the first question I got about this. The second one is about this part of the assignment. So first of all, you're just supposed to think about, if you were a juror, what level of confidence would make you feel comfortable, or what level of significance for a hypothesis test would make you feel comfortable. So keep in mind that those two things are related. So if we're doing a confidence interval, we have our confidence level. So let's say we picked a confidence level of, I don't know, we'll pick something different, 92%. That means for our alpha, it's 100% minus 92%, so that's 8%. This alpha is related to the alpha for a hypothesis test, which for a hypothesis test, that's called the significance level. So for this part of the assignment, really all you need to do is think about the confidence level, and you can use that to determine your alpha, and then you can use that to put into the minimum sample size formula. So don't worry too much about the significance level for the hypothesis test, because that will kind of come automatically from picking your confidence level. So really all you need to do is think about the confidence level that you would want. Now, as far as using the formula, I'm afraid this wasn't totally clear because it talked about chapter 7 notes, and that's actually the notes for week 10. So here's the formula that we're looking at, because in this project we're talking about mean salaries, so we have to use the minimum sample size formula for a mean, which is this one. So the reason that we have to decide on the confidence level is in order to get this critical value right here. But I've also had a lot of questions about these other 2 things in the formula. So this sigma star is an estimated standard deviation. And for this, you don't really have an idea what the salaries might be. So what you need is to really estimate this. And for this, you can use the range rule of thumb, which says that an estimate for the standard deviation is the range divided by 4. And the range for the salaries is something that you could at least make a guess at. So if you think about the salaries for managers at Walmart, and keep in mind that the legal case that we're talking about is a little bit old. It's probably 10 years old. I can't remember exactly how old it is. But so the salaries for managers at Walmart 10 to 15 years ago, if you can think about maybe a minimum, reasonable, and a maximum. And again, this is just your best guess. There's not really a right or wrong answer here. So for example, I might think the minimum might be, I don't know, $20,000 to $25,000. The maximum maybe $60,000 to $70,000. Anyway, just come up with your own estimate for those two numbers and then find your range once you've estimated those two by taking the maximum minus the minimum. So whatever you make a guess at for these two numbers, then subtract them to get your range, and then take that value and divide it by 4, and that will give you the estimated standard deviation to use in the formula. Now the next thing that you need for the formula is the E. This is not a calculated E. This is like what we did in the last project with the M&Ms. We were trying to think of a maximum margin of error that we would want for our confidence intervals. So for this one, we're trying to think of a maximum margin of error E that we would want for our confidence intervals, and these confidence intervals are going to be for the mean salary of the Walmart managers. So we want to think in terms of probably thousands of dollars. If we're going to try and estimate the average salary of a Walmart manager, we want to have a confidence interval that goes above and below our point estimate by however many $1,000 we think is reasonable. So this is going to be something in thousands of dollars. So think about that and think about what you would think was reasonable. If we're going to say that we think that the average Walmart manager's salary is between this number and this number, how far apart would you think was reasonable for those two to be? I mean, would you think it was reasonable to have an interval that was $5,000 wide or $10,000 wide, or just make an estimate for yourself? So once you have those three things, so you're going to have to figure out your critical value based on your confidence level. So figure out that, figure out your estimated standard deviation, decide on a maximum margin of error that you'd like, then put those three things into the formula and do this with it. That's going to give you a minimum sample size. Now for this, the idea is that the sample size you're getting is only 40. So if this comes out to be a lot more than 40, then you're going to have to change some of your design choices. Mostly what you want to do is change your confidence level, because you really can't change your estimated standard deviation. I mean, that was a guess anyway. You could change your maximum margin of error, but the most important thing that we're looking at is this critical value. So remember, if you want to make this number smaller, then you have to lower your confidence level. So if you put your numbers into this formula and this comes out to be way too big, then what that means is either you've made your margin of error way too small, or you've made your confidence level too high. Now for confidence levels, probably the lowest that we want to go would be 90%. Anything less than that is really not going to be good, since we're thinking about presenting evidence for a trial. So the lowest that I would want to go for a confidence level would be 90%, but you can also change your maximum margin of error. So if you make this something really small, like $1,000, then you're definitely likely to end up with a sample size that's too big. So just keep working on especially this and also the margin of error until you get a number, an answer for this that's 40 or less. So that's the idea for that assignment.